I just wanted to review a few quick things before we go on with more videos. When you're looking at these problems, I've got 4 different examples listed. I'm going to go ahead and write out the equation and the K values and then kind of go through writing out the ice charts. And I'm just going to try to be really consistent on how I write it to keep the information organized and doing it the same way every single time. Now, I actually intentionally have certain compounds set up. I just realized I didn't change this one. There we go. I have something that has a Ka value of 1.8 times 10 to the minus fifth. And I have something else that has a Kb value. It's the same value. It's so crazy. These are the only 2 that happen to have this work out this way. But it's kind of nice to do these for the example. Again, that's the Kb value, and this is the Ka value. All right, so if we're going to write a reaction with the CH3COH, and you write it by adding water. Now, I'm writing it as HOH. Now, this guy, this is that COOH Cu acid kind of a thing. He's the one that's got the H. He's the one who's going to want to give it up. He's not going to want to accept an H from the water. So, right here, he's giving that H to the water. And then we've got our little reaction. And so we're left with CH3COO minus plus H3O plus. Now, don't start the ice chart without going ahead and writing out that this is a K, what do we make? Acid or base? That's an acid. That's literally what's floating around that gives us that pH measurement that messes around with everything in our bodies. That's really important to the entire world. That ion right there, because that's the same thing as H plus. So this is a Ka. So when you make that, Ka. And so then I'm going to go ahead and write CH3 plus times CH3COO minus, so it's just this one and that one, over CH3COOH. And then when you fill it in, these are all going to have a really similar look to them because for the weak stuff, they only, and well, for acids in general, they only give one H up at a time. So you should be looking at a minus X and just an X and X. You're not going to be worrying about the coefficients in this section of the chapter. You'll come back to it in the next section when you start dealing with insoluble salts. You will see salts in this chapter, but they're not insoluble. I know that sounds crazy. So you would have a value here, and both these values would be 0. So I can write that as like an I. And then the water doesn't ever matter because it's a liquid. We don't put water as a liquid in. And remember, this is I minus X, this is X, and this is X. So that's how you really neatly set it up, and you make sure that you've got this written as a Ka to begin with. There's a really important reason for this. Now I'm going to write this one out, HOH, as a liquid. Let's go back and forth. So I've got, now this NH3, it's got a lone pair right there. It doesn't have any H's to give up. He'll accept an H, but he doesn't have any H's to give up. So that becomes NH4 plus and OH minus. So now I've made an OH. Again, this is the OH that affects our pH of everything. That's what's floating around affecting it. So that is a Kb. And then we're going to look it up, and you would end up with NH4 plus. Plus OH minus. Sometimes people are even really particular. They always make sure that like this one ends up in the right position. So you can do it that way too. And then we have NH3 right here. And then notice, of course, I've got this Ka. So I know that that is 1.8 times 10 to the minus fifth. It's actually very useful to go ahead and write this down before you fill out the ice chart also. 1.5 times 10 to the, 1.8 times 10 to the minus fifth. Just writing it down and having it all there. Then when you finish the ice chart and you look up, you actually can kind of see what you do next. Now, in this chapter, in the second part of the chapter, you're also going to see things that have charges. Now, if you take something with a charge and you react it with water, that charge thing is going to want whichever part of the water is the opposite charge. So like the H part of water or the OH. Which one do you think the negative is going to be attracted to? Yeah, the H. So this is going to go, and it's going to look like CH3COOH plus OH minus. So that's what's left over. So since that's left over, this is a Kb reaction, the OH is. And then you're going to end up with CH3COOH times OH minus over, sorry, my things are so messy, CH3COO minus. Now, when you go to the KB chart and you try to find the KB for this, it won't be listed. It just will not be there. You can look and look and look. You will not find a KB value for this. But you will find a KA value for this. And so what you do is you say, well, I can get from the KA to the KB using the KW of water. So what I often will do is I'll go ahead and I'll write this and I'll slide this over right here, and then I'll put KW over KA equals that one. So that I actually know that it's already there. And so, like, for example, in this case, I do have the KA value right here. And so I can say 1 times 10 to the minus 14th over 1.8 times 10 to the minus 5th equals this. And now I can fill in everything to do with my ice chart. So I like to write it like that. And then finally I have my NH4 plus my HOH going back and forth, and I'm making in, okay, he's got an extra H. He's positively charged, so he's going to be interested in the negative part of the water. So that makes it in, and he's, and actually what he's trying to do is he's not trying to grab the OH group. When he's acting as a base, as an acid, this one is an acid, it's actually going to be giving the water an H+. That's how this one works. So it's not so much about the attraction to the HOH as it is about trying to give up that H or accept the H. So this becomes NH3 plus H3O plus. Notice we make that, so that's a Ka. When you look on the chart for the Ka value for NH4 plus, it will not be listed, but you will, if you jump to the Kb chart, find that one. And so again, Kw over Kb, 1 times 10 to the minus 14th over 1.8 times 10 to the minus 5th. That is equal to your H3O plus times your NH3 over your NH4 plus values. I don't know, hopefully that helps. Keeping all the information organized and how to get between different things and how to know what you're solving for, whether it's KB, Ka, or what it is, and how to get between them if you don't have the right one.